talk about how to test and monitor your large language model integrations. I'm Dennis, and I'm the machine learning lead here at Voiceflow, and I'm excited to share what we've built in-house today. So to get things started, I wanted to talk a little bit more about our business. So Voiceflow creates conversational AI assistants and products for our end customers. We have over 60 enterprises using our platform, and when ChatGPT came out, it was a huge impact on our industry. So what did we do? It all started at the end of November, as many of you might have remembered, with ChatGPT coming out. And we were thinking for a couple of weeks of what is the best course of action, because a machine learning model that can interact with users in a conversational manner does shake up the conversational AI industry. So what we decided was to create a hackathon and build out 9 features for our platform. So we started on December 13th, and we built this over the course of a week and a half, went on winter break, and then returned and launched this to our customers. So there are 2 types of features that we included. First one was creation time. So when you're building your conversational assistant, you would input various data and information to the platform, and we used the GPT models to augment this and let you build data and features faster. We also enabled runtime features, so you could actually send prompts during the conversation to the GPT model and receive some kind of response based on this. So in this context, we're using a persona of a server for a restaurant, and we're injecting some context based on the past form of dialogue. So these 2 different use cases had quite different requirements, but we thought about how we could serve our customers for both. Now, one of the most important things in both use cases is actually letting customers and our customers' users know that they're using a generative model. So we added these disclaimers within our projects to say, you're using a third-party model, there are risks involved. There's been a lot of work identifying limitations and risks of large language models, so we wanted to articulate some of that here. And then on the right-hand side here, you can see that little AI icon. So when you're actually running a Voiceflow project, you can see that we tell you that this is generated by AI using one of the steps. Now, what's interesting here is that a lot of companies try to hide whether or not something is AI-based or not. In the past, it's been, oh, we use machine learning or AI, but it's actually somebody in the background labeling it. And now there's a lot of platforms pretending that something is human, but we're actually using large language models. So we just wanted to be very transparent here in the name of observability to make sure that customers know what's actually happening on the platform. This was especially important to get enterprise buy-in since we do work with a lot of large organizations. Now, once we actually deployed the features, we wanted to measure what does success look like. So we use some analytics here. Here are 3 examples of events that we were capturing. So we were figuring out when people actually used our AI generate features at creation time. And then we also tracked the results and the results judgment, which is the user interaction. And the reason we did this was we wanted to make product decisions based on data. And when we created these new features in our product requirements doc, we clearly outlined which events were important and how those translated to technical requirements. We use Segment for this recording, which we already have in the platform, and then we streamed it into Google BigQuery for downstream analytics. So how does this all fit together? This is a high-level architecture of how we connected with OpenAI and integrated our models. So we already had a service called ML Gateway, and ML Gateway was where we connected our ML models from other services. So we use a pub-sub architecture, but we connected them to the front end, which we call Creator here. So Creator is our main front-end product. It would make a request to the ML Gateway, and then based on whether or not it's a generative request or some other ML request, we would route them to the correct model. So all we had to do was add in a couple more endpoints to the ML gateway to enable these features. And we also needed to add in some other tracking information and other auxiliary information for generative models. So these things included usage data. So we give users a certain amount of free tokens, but then cap them unless they're on a certain plan. And then we also validate the prompts as well. So these were things that we did not have in our initial ML architecture that we needed to add in when releasing these features. So when we are actually releasing the features, we had to do some prompt engineering. And these are kind of the two main issues we ran into. So the first one was formatting. So making sure that for the different types of features we enabled, that the formats and the parsability were correct. And then the second one was how do we deal with challenging topics and topics that our customers might not want large language models to provide an opinion on. So for the first option on formatting, we ran into a couple families of issues. So the first one being non-parsable JSON. So we standardize our outputs in a JSON format. So what would happen is that when we had responses generated, sometimes the GPT-3, ChatGPT, or GPT-4 models would provide incorrectly parsed information or non-parsable information. In this case, you can see that there is a rogue comma at the end of this generated phrase, but also some code escape characters, probably from a code generation capability within the model. So we then had to write some error handlers or parsers that could convert this malformatted JSON into usable JSON. We also had other just formatting issues, things like quotes being missed, escapes of quotes, and all these different things that would break a software program, but could happen due to the generative nature of large language models. So we added these different transformations to handle these use cases that we saw in production and optimized to reduce the formatting errors. Another issue we saw was stop sequences. So this was pretty interesting, is that we would see these errors pop up intermittently and say, why is this user not getting a response back? Or even when we would be building a response and testing our own product, we would see these issues. So what happens is some prompts just produce a stop sequence. And this is something non-deterministic that you can't actually test unless you run it. So we were thinking about how can we actually augment this problem with a combination of retries or using a different model. And what was interesting is when we moved from GPT-3 to ChatGPT or GPT-4, this issue disappeared. There are also other ways to potentially modify user prompts to remove this issue. So these are some of the things that we ran into building that sort of additional customizable layer on top of these large language models. Now, generally the structure that we would take, so earlier you saw that table of errors per different API call. We would take those errors and we would feed them into a test suite that we developed based on past information and past failures and our own set of handwritten cases. And whenever we wanted to test a new prompt, we would feed the errors and test cases along with the prompt into our test suite. And then if things passed, we would then upload that into our prompt store and use it in our next release. So we went through this iterative cycle to validate that things were working. And along the way, we discovered sort of these families of issues. Other things like weird Unicode characters or strange encodings we ran into as well. So before we made any new releases to our prompts, we would put it through this test suite. Now here's an excerpt of an early version of that. So going through and iterating through different cases, parsing some JSON, validating prompts, and then here in sort of an explicit debugging mode, we can see that we're having some issues with JSON parsing here. So you can see here standard issues, commas, double quote, escapes, weird characters. This is kind of what it looked like. Now for formatting, what's interesting is that you could fine-tune large language models to have it get better at actually providing responses. Now this was true. We tested this out. We used DaVinci for most of our use cases, but decided for some use cases what would happen if we fine-tuned the smaller GPT-3 model, which was Curry, in order to get better formatting results. And we did, but Curry did not perform as well on the actual requests and questions. So in this use case we're outlining, this is a document retrieval and Q&A flow that we've built out. And the requests in Curry are processed faster, they're more structured, but unfortunately they're not as accurate. So this is also a cost trade-off because fine-tuning these models and using fine-tuned models is more expensive. So we ran the tests and determined that using sort of vanilla GPT-3 with some prompt engineering was good enough for the first release. So here's a specific example where there are some errors. So this was a quote from one of our articles about NLU design, and DaVinci gave a correct answer while Curry made some things up. Now we also tested out ChatGPT Turbo when it came out, and it gave roughly a similar quality as GPT-3. So here's again sort of a debug hand run mode that we did to do some initial tests and then decided whether or not we'd put it through our full test suite. So you can see here, the timings are roughly similar, the answers are roughly similar, but ChatGPT is more verbose, and it's actually not that much faster compared to GPT-3 because generating those extra tokens takes time. So then it's a consideration of, do we rewrite all our prompts and validate and test them for ChatGPT Turbo? Is that worth the engineering time of switching over models? Because engineering time is quite expensive. So this was a decision that we had to make for our internal prompts. And the initial decision was we wanted to keep building new features, and we are currently satisfied with GPT-3 performance. And then GPT-4 came out. So what's interesting is that GPT-4 is a better model, does better formatting, but it's not a slam dunk for how well things work. So here's an example of 4 questions that we can ask a knowledge-based system powered by Voiceflow, powered by GPT-3 versus GPT-4. So the first thing to notice is that GPT-4 is much slower, and for a Q&A system, it's way too slow. Any user using the system would get bored and not actually use the system for its intended purpose. So you get better technical performance, but not better UX. It's also more expensive. In our case, it was 3 to 4 times more expensive based on the token costs. And it was also not an exponentially or significantly better experience to deal with the trade-offs. And you can see here in the second question that we asked, GPT-4 actually provided the wrong answer or didn't summarize correctly. So this is something we're continuing to experiment with both GPT-3 and GPT-4, especially given the formatting changes of the ChatML structure versus just a completion format. What we ended up doing is for each of our user models, we let users choose which models that they use. And for our own provided sort of pre-built features, we're still iterating on what the best models are for which components. So large language models can break for a number of different reasons. And one of the things that we noticed is that we got a lot of 429 errors with OpenAI. So this was quite common, especially in the early days, given the massive popularity of ChatGPT and LLMs in general. But whenever we were building out these features, we had to have this as a consideration. So what's the UX implication for a product feature? That was super important. What was the implication for custom prompts that users provided, and how would our backend handle those timeouts? And also for custom APIs that users wanted to use within the platform itself. We actually had to up our API step timeout because it originally wasn't designed for such long-running tasks. Now, the other interesting consideration here is that even if you do all this fancy like observability or I guess best practices for software in terms of retries, exponential retries, all these different things, the user does not care unless they get the response they want. And because large language models take so long, they'll just keep hitting that refresh button. So doing exponential retries or even consecutive retries might not work for your use case. Now here's an example on a demo app we deployed internally on a staging environment. So we saw that some of these timeouts were quite large. So you can see some spikes there in March, the staging environment, going to over a minute for a P99. So a minute for P99 for a Q&A system is way too high. So we ended up figuring out how can we work with OpenAI to reduce some of those latencies with existing plans. So very important to consider when you're building a new application, whether it's a API straight from OpenAI or going through the Azure platform, what are your SLOs and how are those impacted by demand for the product? And we get this other question of what happens if OpenAI goes down? So there's been a lot of companies popping up that are purely based on generative features from large language models. And it's a real concern because there have been days where OpenAI has completely gone down. Outages in February and March, so far April has been pretty good, but that makes you ask the question of what are your SLOs? How are you actually guaranteeing uptime for your customers? So this is super important to consider because if your application solely relies on one large language model vendor and you promise 3 nines and a 5 or 4 nines of reliability, that might not actually be feasible. So you might have to run a multi-LLM architecture in that case. Now this gets into this sort of trade-offs of what are our data considerations. So this graphic is borrowed from general data engineering from AWS in terms of running different setups for your services or data services. So on the left-hand side, you can run simple setups with lower uptime guarantees, but they're cheaper and faster to implement. All the way to the right side where you're running multi-site, multimodal, multi-cloud setups that are much more expensive and complicated to run, but you get benefits in terms of uptime or reliability. So something definitely to consider because 4 nines of reliability for large language models is very hard to hit. In most cases might not be necessary. So then we get into the question of deploying your own models. So if OpenAI is unreliable or another vendor is unreliable, how do we get these uptime requirements? So you could deploy your own models. Here I've sort of outlined this matrix of whether something is self-hosted or self-trained. And in the bottom left, we have something like OpenAI or the other vendors where you have large language models as a service, not to be confused with llamas. But large language models as a service, you get everything out of the box. Then as you move either to something more self-hosted or self-trained, it gets more customizable but more complicated. Now here's an example of some of our own processes running. So on the left here, we're fine-tuning on OpenAI. You see here that we're in a queue for fine-tuning. It takes a certain amount of time to train. So it actually takes us a fair amount to actually train a model due to this third-party service that we would depend on. But it was very easy. It took maybe 20 lines of code after we configured our data set. On the right-hand side here is a custom platform that we built at Voiceflow, powered by our ML CLI, where we run custom training. So for these custom training workloads, it's just us as the customer, so we have full control. We can fully change how we do fine-tuning, but this is a complex system to build and manage. So there's obviously trade-offs, and we've been considering both in our case. Now, for deploying your own models, there's been a bunch of new technologies that have been released in 2022 and 2023, and they'll continue to be released, but it's becoming more and more possible. We're seeing things like FLAN-T5 as a model come out in 2022. There's a big paper on 8-bit inference as well, and running larger models on smaller hardware. And we're seeing even more progress with models like FLAN-UL2, Llama came out, even though it's not fully open sourced, and there's been more papers recently on things like 4-bit inference or 3-bit inference. So the space is quickly catching up where you no longer just need to integrate with a third party. It's becoming more and more possible to manage your own large language model. So that wraps things up. Thank you for joining us on our journey on how we've built integrations for Voiceflow's generative capabilities. We covered quite a bit today, going through the use cases, our observability and monitoring approaches, and also some of the issues that we ran into when integrating LLMs into our product. So thank you for joining, and looking forward to any questions that the audience might have.